Okay, guys, so welcome to another class. So, in the previous lectures, actually, we've talked a lot about the projections of the planes, but whereas most of you wanted to listen to this topic again, so I'm going to take one problem today and I'm going to explain that in the AutoCAD so that you guys will be able to understand what am I exactly talking about. So let us not waste any time, but before I was going to start today's class, I just want to remind you guys about the previous session. So in the previous class we have taken two different planes, two different problems in which both of the planes are actually resting on the sides. So here now, in those particular problems, we have encountered certain in those problems we've learned something new, but whereas at the same time it seems to be getting somewhat complicated. So in order to decrease that complexity, so I'm going to what I'm going to do now is I'm going to show that whatever that I want to explain in the AutoCAD, so that you can understand what am I actually trying to say. Because whatever the thought process that is actually happening inside of my brain, I just want to show that in the pictorial three-dimensional representation in the AutoCAD, so that you guys can understand what am I saying. So let me open AutoCAD first. I'm going to take one problem today, which is this problem. Let's forget about the conditions for now. A regular hexagonal lamina of 30 mm side rests on horizontal plane on one of its sides, which is on horizontal plane makes 60 degrees to the vertical plane, and surface of the lamina is inclined to the HP at 45 degrees. Draw the front view and top view of this lamina in its final position. So first of all, this is a regular hexagonal lamina. So hexagonal means which is the lamina which is having 6 different sides. Okay, so which is known as the hexagon. I think all of you might have already known about these things. Sorry. So the each side of this hexagon is having a dimension of 30 mm, and this particular hexagon is actually resting on the horizontal plane using one of the sides. It has 6 different sides. So on one of these sides are actually in the HP, and the rest of the sides are not in the HP. Okay, which means it is making certain inclination with the horizontal plane. That is what obvious, right? Since only one side is actually, if all the sides are resting on the horizontal plane, means it is actually of course obviously parallel and parallel to the horizontal plane. But whereas now, since only one side is actually there on the horizontal plane, means and the rest of the sides are not there, which means this particular plane surface is actually making certain inclination with the horizontal plane, and the side which is on HP makes 60 degrees to the vertical plane. So it has 6 different sides, and the one of the sides is actually resting on the horizontal plane. That particular side or that particular edge is making an inclination of 60 degrees with the vertical plane. Don't worry, I'm going to show that to you guys, in the three-dimensional view first, and then only I'll go to the two-dimensional view. Before earlierly I have to explain this one, so that's the reason why I might go to 2D, but entirely I'll try to explain this one in 3D, and then I'll try to draw this one in 2D. Okay. And the surface of the lamina is inclined to HP at 45 degrees. See, I've told you earlier, since one of the sides is actually in the HP means, rest of the sides are not in the HP means. So the plane surface is actually making certain inclination with the horizontal plane. So that particular angle here is 45 degrees. Okay. He wants us to draw the front view and top view of this particular lamina. In its final position. Okay. I'm going to use the press pull. It's taking longer than I actually thought. Say 0.1. You can use the extrude command also, since it is a closed region. We can use the press pull command too. Let me go to the left side view. I just want to move this thing. What? Something is wrong with my AutoCAD. Something is definitely wrong. Yeah, they are. Now let's use the rotate command. Okay. Okay. This is a horizontal plane and this is the vertical plane. Now let me create the polygon that I want to. There are two different ways in which a polygon can be created. This is also a hexagon. This one is also a hexagon. But which shape has to be chosen? Whether taking two different edges perpendicular to the VP or taking two different sides parallel to the VP. It actually depends on the given problem. Okay, so let us read out the problem. So a regular hexagonal lamina of 30 mm side rests on horizontal plane on one of its sides. See, one of its sides. So one of the sides of this particular hexagon has to stay on the horizontal plane. Assume that this is the figure that you have chosen in order to solve this given problem. This is the shape that you have chosen instead of this one. These two sides are perpendicular to the VP and these two sides are parallel to the VP. Which one we have to choose? See here. The thing is, if you want to keep one of the sides of this one, what happens to the rest of the sides? They have to be rotated, which means it is about to make certain inclination with the horizontal plane, and as well as this surface obviously makes certain inclination with the vertical plane also. You may take any edge. Let us try to take this particular edge here. So let me use the 3D rotate command. I think it's 2D rotate. I've selected this particular edge here. Okay, I'm gonna try to rotate this one by a certain inclination. Something like, what's wrong with this one? Yeah, let me select this particular edge. I'm gonna try to rotate this one only this particular one. Okay. Then extra. That is going to be difficult. So what we can do now is we have to choose this particular shape, because even though both are hexagonals, I told you the difference. Suppose if I kept this edge here, if I lift the rest of the 5 different edges, so what happens? So this particular only this particular surface will make inclination with the horizontal plane alone, but whereas if I was to consider any other edges here, it is going to be difficult. But whereas I don't have any provision if I have to select this particular shape, so that's the reason why we have to say you have to you know choose this particular shape. ఇప్పుడు ఒకసారి తెలుగులో చెప్తాను. ఇక్కడ ఏంటంటే, సో ఇక్కడ మనకి ఇలా రౌండ్ కార్నర్స్ ఉన్నాయి కానీ బోత్ రెండు కూడా హెగ్జాగన్సే. బట్ ఏంటంటే మనం హెగ్జాగన్ని ఇలా డ్రా చేసుకున్నాం అనుకోండి, అప్పుడు మనకి ఒక సైడ్ని చూస్ చేసుకుని మనం ఏం చేయాలి, ఒక సైడ్ని మాత్రమే హారిజెంటల్ ప్లేన్ మీద పెట్టాలి, మిగిలినవన్నీ కూడా హారిజెంటల్ ప్లేన్ మీద ఉండవు. సో అంటే అవి హారిజెంటల్ ప్లేన్తో ఎంతో కొంత యాంగిల్ చేస్తున్నట్టే కదా. సో అది మనకు ఇప్పుడు అలా లిఫ్ట్ చేయాలి అంటే ఇందులో ఏ ఎడ్జ్ని తీసుకుని మీరు లిఫ్ట్ చేసిన హారిజెంటల్ ప్లేన్కి వెర్టికల్ ప్లేన్కి కూడా ఇన్క్లినేషన్ వచ్చేస్తుంది. మనకు కావాల్సింది ఓన్లీ ఇన్క్లినేషన్ విత్ ద హారిజెంటల్ ప్లేన్ మాత్రమే. ఓకేనా? సో అందుకని మనం ఈ పర్టికులర్ షేప్ని తీసుకుంటాం. ఓకే, సో హియర్, so I am going to select this particular edge in such a way that it is going to be give me only this 45 degrees inclination with the horizontal plane alone. Okay, so if a plane something like this is actually resting, means so from the front view, okay, so from the front view it will just look like a, actually this one is actually resting on the horizontal plane, so we will get the straight line on the XY line, but whereas for our convenience I have drawn the line somewhat above the XY line. Okay, from the front view this particular plane is actually looking like a straight line, just a straight line. So that's why what I'm going to do now is I'm going to choose a line like this. Let me mark this one as X. Okay, I think the dimensions might have got messed up my viewport. No problem. Just enter a enter. Which is behind the scene. Yeah. Now I'm going to draw this hexagon here. 30, 30. Oh wait. This one has to be vertical. Okay, we have drawn this hexagon here. I'm going to draw the projections. The line has to be taken from this particular line. Okay, see here, we will get a straight line on this XY line. Okay, since we will be able to see only a straight line from the front view. Okay, let me give a different color to these lines. Yellow. Okay, these are projections. I'm giving the namings here. To the front. A dash, B dash. C dash, F dash. So yeah. E dash, comma, D dash. Okay, so let's move to the next step, or the first condition. Resting on HP using one of its sides. Sorry. Which means I have to copy this one. Let me select this and let's rotate. Wait, before that we have to choose the pivot point. That's the pivot point about which I want to rotate. The angle is 45. Yeah, right now. See here, we are satisfying the first and third condition at a time. This one has to rest by by one of the sides of this particular hexagon. Okay, if it is resting by using one of the sides, means rest of the sides are not on the plane, means this surface has to make certain inclination with the horizontal plane, right? With the horizontal plane it has to make certain inclination. That inclination was actually given, so that's why we can satisfy both first and the third condition at a time. Clear? Now, so from the front view it will just look like a straight line. I'm going to take this one somewhat further because I don't want these edges to be messed up. Okay, this is how we can see this one, right? From the front view, this entire plane is looking like this straight line. So what we are going to do now, obviously we will now have to, let me give the markings. We use the trim command. A dash comma B dash. So whatever the line dimension that we're about to get here, (51.96). I'm going to take a line 51.96 and 45 degrees inclination. So this plane will look like a straight line of dimension 51.96 and at an inclination of 45 degrees. Okay, I hope it is clear to you guys. So I'm gonna just mark the markings again and copy the edge. One. Okay, so I'm going to draw these projections. So A dash and A projection are about to meet here, and F dash and F projection are going to meet here. Similarly, rest of them are meeting at these specific locations. A1, copy that. B1, C1, E1, F1. Okay. So what's going to be the next step? The final step and the second condition that needs to be satisfied is, wait. Before that, I'm going to draw them in the top view so that you will be able to understand what am I trying to say. No, it should seems like it is, yeah. Actually, I think I might have drawn this line for somewhat larger dimension. That's fine. If you want to know how the top view will look like, so right now I just wanna take these dimensions here. So from the top view, it's looking like this. I'll give green to this one. No, I think I haven't connected these two. So I'm gonna represent the front view with red color. Here also I'm gonna use the red color for the front view. For the top views I'm gonna use the green. Okay, now let's take this one again, copy that, drag it, okay, that's fine. I'm gonna move this one a little outside. Okay, so what's the second condition? The edge on HP making 60 degrees with the horizontal plane, which means this particular edge right here, it has to make 90 degrees, sorry, has to make 60 degrees with the vertical plane. So for this to this vertical plane, right now this one is perpendicular, right? So now this has to make an inclination of 60 degrees. That is what we need. What we're going to do now is we will going to select this one, yeah, polyline, select 3D rotate, take this one as the assume that this one, yeah, Okay, so here, so when this particular edge, if you assume this one as the this particular edge right now here is making, don't worry, if I don't open that, this navigation panel is not coming to me. See, from the front view it is looking like this, so we have to draw these projections. From the front view it is looking like that, and from the top view this one is so for the front view I'm going to use a red color. Yeah. My system is lagging. Now this red colored shape and the green colored shape, we should get them in this drawing. That will be possible. So we haven't done anything great here. So what I've actually done is I have taken this dimension as it is. So I've just rotated this edge. So this green color portion, this green color portion having the same dimensions. Their dimensions won't change because I haven't inclined that one with respect to the horizontal. If it is made with respect to the horizontal, again if this one is made some inclination or increase in inclination with the horizontal plane, then there is a chance that the dimensions will change. But whereas I haven't changed anything, so I'm going to take this figure, and before that let me mark all the dimensions here. Alright, 18.37. 15. I'm going to use the offset command. $18.37. Then I'm going to take the offset. Okay, so I have to measure the angle as well. No need to. I'm gonna just this dimension is I don't know the dimension. Okay. Now, so at a distance of 15 along this way, draw a line. This is what I don't want. So with the 38 I need 60 degrees line, right? That's why I'm so concerned. If I don't take these properly, 18.37 is fine. Alright. Now 30 is fine. $30 plus. Oh, I have to take an offset to this one. 15. That's fine. Now I'm gonna take again offset to this one. So now 30. Now I'm gonna select offset again for 15. Now I can just add them on. I know these points. Cut the extra line. And okay, now everything is set. So what I'm gonna do is I'm gonna just draw these projections. Don't worry guys, I will give you guys this AutoCAD file. No, nothing else. Now, similarly from these locations to straight line under this one. I need this projection. B, C, D, E, F, A. So when I trim all of these things, you guys will came to know okay. Dash A1 dash. This one has to be B1 dash. You still need to simplify this one a lot and give a lot of color coding. Yeah, A1 dash. This one is giving me a lot of trouble. Let's forward this. Okay. Since I'm giving the red color to be front view, yeah, that is so. Okay. Let me come to the 3D again. See if there is a way to copy all of them. What are you going to specify? It is asking me to specify the insertion point. Okay. Oh, alright. I think okay, that's fine. A1. సలద్దాం మళ్ళీ రొటేట్ చేయడానికి కొంచెంసేపు ఇచ్చిన టైం తక్కువ. గైస్ మీరు అందరూ ఇంటి దగ్గర ప్రాక్టీస్ చేస్తున్నారని అనుకుంటున్నాను. ప్రాక్టీస్ ఎక్కువైంది. What the? The reason I'm doing this one is I just want to give you guys this AutoCAD file. If I don't do this right now, you guys will get confused. T and then two more to go. Okay, if you guys have any doubts, see this one at once and this two files so that you will get an idea of what am I actually saying. Okay, if you observe these two closely, then most probably 90% of all of your all of your doubts will be clarified. Okay, if you still have any doubts, post them in the Google Classroom. I'm happy to answer them all. Okay. Oh, with this last lecture today, I think the projections of planes concept became very clear to you. So I just want to wrap up this session. So, so we have seen in these projections of planes different laminas. Their resting positions. Some of them were resting, resting with the sides, and some of them were actually resting with the corners. And we have seen so many different types of planes, and especially this one. So I've taken this problem as something very challenging. So if I want to explain a single problem in an hour class, I can do that, but whereas it is going to take a long time, so the time that we have is not much sufficient. Okay, but still, if you guys want me to, I could do 2 to 3 videos. Okay, let me know in the Google Classroom. Post them in the Google Classroom if you still have any doubts. So I'll talk about this today problem. And initially we have look for the position of this hexagonal plane, and how does it needs to be placed, so that when we are trying to lift rest of the 5 edges, when only one edge is actually resting on the horizontal plane, and we have chosen that position, and how does it actually looks from the front. And from the front, yeah, it just looks like a straight line to us. And after that, we have rotated that one to 45 degrees, satisfying the third condition, and still it looks like a straight line from the front view. And how does it actually looks from the top view? We have drawn those projections also, and we have taken that projection, and particularly the side AB, we just still want to keep this on the horizontal plane, and after that we want to rotate, we wanted to make this plane rotated by 60 degrees, so that we can achieve the second and the final condition. We have achieved all of them, and we have drawn the final front view and final top view. Guys, I'm going to attach this AutoCAD file, so that if you have any doubts regarding what am I actually explaining here, you can just watch it. If you have an AutoCAD installed in your PC or laptop, I suggested you already to install it, that one. I hope all of you, most of you might have that one, have that software in your laptops. And that too, for you guys civil people, it is essential. Remember that most of the civil people, not only most of the people, everybody almost requires AutoCAD, because whenever you want to convey certain drawing or about a building or something, then you must know AutoCAD. AutoCAD is famous for drawing these building plans and all, so we can produce the drawings in a very quick amount of time. So learn about this one. Okay, I hope all of you guys have it in your laptops. Open your laptops and use this, open this 3D AutoCAD file that I've given to you, and I'm going to give you the second file also, the problem that I've solved today. So look at both of these files at once. If you guys still have any doubts, I think there may be some online applications are also there, okay, in which you can actually view these .dwg extensions. So look for them. If I found any particular apps like that, I will look after them. I will let you guys know, since most of you may not be having laptops and all of them, right? Okay, if you guys were okay with this session, just let me know, or otherwise I'm going to start projections of the solids concept. I'm about to, because if I started this one right now, because only isometric projections will be left in the AutoCAD part, I'm going to cover that one also. Okay, projections of solids. If you're completely okay with this planes concept, in case of solids concept, it will become very much easier for you guys. Okay, that's my suggestion. So don't skip the classes. I'm repeating once again. Tell your friends to attend the classes. Tell them not to skip the classes, because once the college is reopened, there won't be much of a classroom interaction. I'm sure there won't be a classroom interaction. So that's why come to the online classes. From today onwards, I'll try to make it live, because electricity power has been stable since yesterday. If this continues to be, then I'm going to be in live. Okay, so in the next class I'm going to talk about I'm going to take some basic solids here, basic primitive solids. I've told you about these different solids, explained about them. These prisms, what is a prism, what is a pyramid, and what is there are volumes that are being generated by surfaces, right? Like if you rotate a rectangle about a certain one of the edges, longer edges, then you will came to know that you have if you rotate this one 360 degrees, you will know, you will find you will make a cylinder out of it. So likewise, there are different types of solids that I've explained in the previous class. Okay, so in the next class we will see some of the problems which are actually related to the projections of the solids, and if I have enough sufficient amount of time, I'll go for the AutoCAD too. Okay, see you guys in the next class. Hope you guys have learned something today.
We know that the planes are two-dimensional entities with no thickness and can be extended to any size. These planes are imaginary surfaces. Do you know the reason for studying these physically non-existing plane surfaces? The answer is simple. If a designer wants to design a machine, for example, a multi-axis CNC machine. Its components can be drawn easily in its simple positions. But he has also the duty to draw the machine elements at different positions. For example, if the tool head turns 30° upward and 45° rightward for a machining operation, it will be very difficult for the designer to draw the whole arrangement by simply imagining the positions. To simplify the task, the designer extracts only the adjoining surface and turns it in the required angle to obtain the overall idea of its position. These planes joining two surfaces may be of hexagon, pentagon, square, rhombus, rectangle, triangle, circle, etc. These adjoining surfaces are planes. To project these planes in an effective manner, the designer uses a method called orthographic projection of planes. In this lesson, we will see the orthographic projection of a plane and the positioning of various planes in detail. Now, consider a square lamina in the principal plane. When a lamina is parallel to the plane of projection, it will be perpendicular to the other plane. Thus, the view of the plane surface projected on the plane of projection gives the true shape of the lamina. The view of the plane surface perpendicular to the plane of projection will be a line and is called a line view. The view of the plane when it is inclined to the plane of projection is known as apparent shape of the plane. Now, let us solve a problem to understand the orthographic projection of a plane. A hexagonal plane of side 30 mm has an edge on the horizontal plane HP. The surface is inclined at 45° to the HP and perpendicular to the vertical plane VP. Draw its projections. Initially, we just saw the simple position of hexagon, but it is very difficult to recognize its inclined position. Hence, we should start with the simple position of the plane, that is, its true shape. With the help of its simple position, we can draw its inclined position to any plane. The first step is to obtain the true shape of hexagon in its simple position. Since it is given that one of its edges rests on HP, that is, initially the plane lies on the HP, the top view gives the true shape. Also, it is given that one of the edges rests on HP and its surface is perpendicular to VP. The hexagon can be drawn as shown with the side 30 mm. Now, the front view is obtained by the projector lines from the hexagon. Since the points A, F, and E are not visible, they are given within a bracket. It is given that the surface is inclined 45° to HP. The angle inclination will appear in the front view. Draw a line 45° inclined to the HP. The points are marked in the inclined line by measuring the values from the front view. Now, connect the projector lines to meet with the locus lines from the top view. The line that intersects the line A and A1 dash is given as A1. Similarly, other points are marked. Now, the points are joined, which give the apparent, that is, inclined shape of the plane. Similarly, the orthographic projection can be drawn from the different planes. In the projection of planes, the first step involves the positioning of lamina in principal planes. We will discuss about the positioning for various plane surfaces in detail. Hexagonal plane. A hexagon has 6 corners and 6 edges. If the problem is given as a hexagonal plane parallel to VP, then the hexagon can be drawn as shown. In this position, the edge or the side of the plane is parallel to the horizontal plane. When the side is perpendicular to HP, it can be drawn as shown. If one of the sides is inclined 45° to the HP, it can be drawn as shown. when the hexagon is parallel to HP. The same can be obtained for all the cases, but the true shape is obtained from the top view. Pentagonal plane. The pentagon has 5 edges or sides with 5 corners. In the problem, if it is given that the pentagon is perpendicular to VP and resting on one of its corners on HP. If the pentagon is resting on one of its corners and the surface is parallel to HP, it can be drawn as shown. When the pentagon is perpendicular to the HP, for the two cases, the pentagon can be drawn as shown. Square plane. A square plane consists of 4 sides of equal length. A square lamina is parallel to HP, and one of its sides is parallel to VP. When the side is 30 degrees to the VP, it will be drawn as shown. When all the sides are equally inclined, that is 45 degrees to VP, it will be drawn as shown. Similarly, when the square lamina is parallel to VP, the true shape is obtained from front view for all the 3 cases. Rhombus. A rhombus is a quadrilateral, with all the sides equal in length. The rhombus has 2 diagonals bisecting each other at right angles. The rhombus with smaller diagonal is perpendicular to VP. The rhombus can be drawn as shown. The rhombus with smaller diagonal perpendicular to HP can be drawn as shown. Rectangular plane. A rectangle has 4 sides, with 2 longer and shorter sides of equal length. If the problem is given that the rectangular lamina rests on the HP and is perpendicular to VP, then it can be drawn as shown. If the rectangular lamina rests on VP and is perpendicular to HP, then the diagram will be drawn as shown. Triangular plane. A triangle has 3 edges and 3 corners. If all the 3 sides or edges are of equal length, then it is called an equilateral triangle. In a triangle, if the 2 sides of the triangle have equal length, then it is called as an isosceles triangle. If the problem is given that if the triangular lamina stands on one of its side on HP and the lamina is parallel to VP, it can be placed in the principal plane as shown. If it is given that the triangle is perpendicular to both the planes, then it can be drawn as shown. When the triangle is perpendicular to HP and its base is in the VP, it can be drawn as shown. Circle. A circle has no corners and edges. If the circle is parallel to VP and perpendicular to HP, it can be drawn as shown. When the circle is parallel to HP or its circumference on the HP, then the circle can be drawn as shown. Summary. In this lesson, we have learnt about the different views of a plane, orthographic projection of a plane, positioning of square, rectangle, circle, triangle, pentagon, hexagon, and rhombus in the principal plane.